So are you saying that the superwave would result in the wiping out of the power systems?
Oh yeah.
What other effects would it have?
The thing is, the superwave on its forefront would have a very dense sort of shock front of cosmic rays. And this would have also an EMP, what we call EMP, electromagnetic pulse, associated with it, similar to what a high-altitude nuclear explosion would do in the atmosphere. Mm-hmm. And when this arrives, it's going to create similar phenomena, just like the starfish explosion. I believe it was near Hawaii, and when the EMP wave arrived, there were whole sections of the island who were having blackouts as a result. It also would fry electronic circuits, phones would go out. We've had even smaller events like gamma ray bursts affect the communication systems and do damage to our communication systems. So something like this would pretty much roast all the satellite equipment we've got. Cell telephones wouldn't be working, TV would be off the air if it depended on satellite. Perhaps telephones would continue to work if it was fiber optic. It was insulated from this sort of thing. Your power lines would pick up the pulse, the wires would have a huge voltage surge which would fry the transformers, the step-down transformers, to go from your million-volt voltages down to your voltages you use in your house.
Wouldn't it always also affect the cars that we have now?
The cars that are all now with chips in them, in a case of a EMP from a nuclear explosion, for example, they warn that it could fry the chips in a car.
And this is something that could last 400 years, you're saying, once it arrived?
Well, the forefront, we're talking about something that might just be minutes.
Okay.
And it would be probably preceded by a gravity wave, which would cause earthquakes, seismic events all over the Earth,
okay,
not just in one place. So that might be the first warning, actually, things shaking. And the longer events can actually start affecting climate, because what they do is they vaporize cometary ice, which is surrounding our solar system, and end up pushing this nebular material into the solar system, and it affects the way light gets to the Earth from the sun. It ends up energizing the sun. It falls onto the sun. The sun becomes more active and more of a flaring star. And actually, the sun ends up then doing more damage to Earth than the superwave itself. The superwave is sort of what gets this dust in, and then you get worse things happening.
So is it possible that solar cycle 24 could be acting on the Earth as a result of a superwave that's going to hit the sun? No. No,
because we're in the in-between period, in between superwaves. The solar system is fairly clean of dust. I mean, if the solar system was packed with dust like the level I'm talking about, we would all see it. You would see the moon being blotted out by a dust cloud, or the sun, huge dust cloud going across the sun. I mean, it would be definitely coast-to-coast news. So we're at both sides of the planet.
Are these dust clouds, aren't they also traveling at the speed of light from the galactic core?
No, the dust doesn't come from the core of the galaxy. It's already around our solar system, and it's pretty much stationary, relatively stationary, just orbiting the sun normally. But when the superwave arrives, it creates a sort of a shock front around the solar system, because the solar system has magnetic fields around it, and it creates what they call bow shock around the heliopause. Heliopause is the name of the sort of protective sheath of magnetic fields around the solar system. And in the magnetic fields, the superwave particles tend to get trapped to some extent and build up to very high levels, enough density of cosmic ray energy to actually start vaporizing ice. And when that happens, so it's actually able to raise the temperature from close to, let's say, 10 degrees above absolute zero up to the level where the ice could vaporize and release both dust and water vapor or gas into space, and this stuff gets pushed in as it's being pushed in by the superwave cosmic rays, because it's like a battle between the solar wind and the superwave cosmic rays. Solar wind is sort of expelling this dust, but then the superwave is pushing this in, and it will actually compress the magnetic field sheath that's around the solar system inward.
Okay.
And it could, in my thesis, which I published in 1983 on galactic core explosions and their effect on the Earth and solar system, I was suggesting that the sheath at the end of the Ice Age actually got pushed in almost to Mars' orbit. And so from there, it's just a short hop for this dust then to come in around the sun, and it would actually produce a cocoon around the sun, so that the sun wouldn't be yellow like we see it. It would actually be reddish.
Is
It
that
was
right?
mainly the sun involved. The superwave triggered the conditions for the sun becoming more active,
Okay.
and also the cosmic dust around the Earth actually creates, in some cases, a warming effect, because it can actually scatter light that normally go out into space back onto the Earth, create sort of an interplanetary hothouse effect.
Okay.
And this was something not only going on the Earth, but also we see evidence on Mars of canyons appear to have been cut by tremendous floods of water.
Yes.
And I believe that Mars is mostly covered by ice sheet. It's sort of like a tundra. And the actual walls of the canyons are actually ice that would have melted during some of these events. Especially there's cases where the Earth was being hit by super-sized coronal mass ejections. We have evidence from the moon of glazed rocks, and one NASA scientist was suggesting that the moon was exposed to very intense radiation from the sun to do this, something like 100 times greater luminosity of the sun for at least 100 seconds. And in my dissertation, I suggested the alternative, that perhaps both the Earth and Moon had gotten engulfed in a coronal mass ejection, and that this was hot enough to actually melt particles